Hello everyone, I am back with a new topic after a long gap. Here we will be discussing about atoms. This video will introduce us to atoms and we shall learn about them in detail in the upcoming videos. Without delay, let's dive into the topic. Generally, atom is defined as the smallest unit of matter that has the characteristic properties of a chemical element. Since thousands of years, atoms have been defined in different ways by different philosophers and scientists. In ancient India, 6th century BC, in the Vaisheshika school of thought, atoms were thought to be eternal, indivisible, infinitesimal, and ultimate parts of matter. Earth, water, fire, and air were considered the four kinds of atoms, and space was believed to have no atomic structure. Rather, it was continuous and inert. The atomic size was estimated to be 10 to the power minus 10 meter, which is 1 angstrom. In ancient Greece, 4th century BC, Democritus gave an atomic hypothesis which stated that the word atom meant indivisible. According to him, atoms differ from each other physically, that is, shape, size, and other properties due to which substances formed by the combination had different properties. John Dalton in the 19th century stated that atoms are the smallest constituent of matter, which are indestructible and indivisible units. Dalton gave the atomic theory, which has been discussed in the subsequent slides. Richard Feynman in the 20th century gave an atomic hypothesis stating that all things are made up of atoms, which are little particles that move around in perpetual motion, attracting each other when they are at a little distance apart, but repelled upon being squeezed into one another. Dalton's atomic theory mainly contains 5 postulates. All matter is composed of extremely tiny, indivisible particles called atoms. Atoms are indestructible, that is, can neither be created nor destroyed. Atoms of the same element are identical in mass, size, and other properties. Atoms of one element differ in mass, size, and other properties from atoms of different elements. Atoms of different elements can combine with each other in fixed whole number ratios and take part in chemical reactions by breaking bonds, rearrangement of atoms, and forming bonds. Now, let us see the limitations of the aforementioned theory. We discussed earlier that atoms were indivisible, but subatomic particles, that is, electron, proton, and neutron, were discovered later by various scientists, which contradicted this postulate. Isotopes are atoms with same atomic number but different mass number and have same chemical behavior, contradicting the postulate that states atoms of same element have same mass. For example, isotopes of hydrogen, namely protium, deuterium, and tritium, have 0, 1, and 2 neutrons respectively, thus have different mass. Isobars are atoms with same mass number but different atomic number. Hence, atoms of different elements might have the same mass. For example, argon and calcium, which have the atomic number 18 and 20 respectively, but both have mass number 40. Several complex compounds, when combining, might not do so in simple whole number ratios such as in sucrose. Allotropes are substances which are formed of the same element but differ in their physical properties. Thus, atoms of same elements might not have identical properties. For example, carbon has several allotropes such as graphite and diamond, which differ in physical properties such as structure, bonds, boiling point, melting point, etc. There are several terms which are important while talking about the basics of atoms. We shall take a look at a few of them. Nucleus is the central part of the atom, where mass of the atom is concentrated due to presence of protons and neutrons. Its radius is estimated to be 10 to the power minus 15 meter. Details about the nucleus and its discovery shall be provided in the subsequent videos. Atomic mass unit is the measurement of mass of atoms with respect to a carbon-12 atom. Hence, one atomic mass unit, which is the mass which equals to exactly 1/12 of the mass of one carbon-12 isotope. 1 AMU is 1.66056 into 10 to the power minus 24 gram. Thus, the mass of an atom is the atomic mass in grams divided by 1 AMU. AMU has been replaced by U, which stands for unified mass. Atomic number is the number of protons present in the nucleus of an atom. It is represented by the letter Z. It can also be equal to the number of electrons in a neutral atom. Protons and neutrons are collectively known as nucleons. Mass number is the number of nucleons present in the nucleus, that is the sum of Z and N, which are atomic number and number of neutrons respectively. In this slide, we shall see the major types of subatomic particles. Subatomic particles are of three types: electron, proton, and neutron. Electrons are negatively charged particles which revolve around the nucleus of an atom. Protons are positively charged particles situated within the nucleus. Neutrons are neutral particles present along with protons in the nucleus. Its chief function is to determine the mass of an atom. This table shows the properties of fundamental particles. The magnitude of charge of proton and electron is equal and opposite, while neutron has no charge. Proton and neutron are approximately 1,837 times heavier than electrons. Now we shall discuss the discovery of electrons. Electrical discharge was being studied in the 1850s, during which cathode ray tube experiment had been conducted by Michael Faraday. It was discovered that the rays contained electrons by J.J. Thomson in the later part of the 19th century. Cathode ray tubes are partially evacuated tubes made of glass containing two thin pieces of metal called electrodes sealed in it. The electrical discharge could be observed at very low pressures and very high voltages only. When pressure is adjusted by evacuation and very high voltage is applied across the electrodes, current flows from cathode to anode, that is negative electrode to positive electrode. Hence, the stream of particles are called cathode rays or cathode ray particles. If these rays pass through a hole in the anode and hit the phosphorescent or fluorescent material present behind it, a bright spot is developed on the coating. Several observations were made after this experiment. Cathode rays are a stream of particles that move from cathode to anode. They are invisible and only visible when it hits the phosphorescent or fluorescent material and they glow. The rays travel in a straight line. The electrical or magnetic field changes their behavior, which is similar to that of negatively charged particles. Characteristics of cathode ray do not depend on the material of electrodes and the nature of gas in the cathode ray tube. Next, we shall discuss the discovery of protons. It was discovered by Eugene Goldstein in 1886. The setup is similar, but here the cathode is perforated. The rays originate from the anode and are known as canal rays. The observations are as follows. Canal rays travel in opposite direction from cathode rays. Mass of positively charged gaseous ions depend on the nature of gas in the tube. Charge to mass ratio depends on the gas. Some positively charged particles carry multiple of fundamental unit of electrical charge. Behavior in the magnetic and electrical field is opposite to that of cathode rays. The smallest and lightest positive ion obtained was from hydrogen, and thus it was named proton. Now let's discuss the discovery of neutrons. Neutrons were discovered by James Chadwick in 1932 by bombarding a thin sheet of beryllium with alpha particles from a polonium source. This caused the production of an uncharged penetrating radiation. The rays were made incident on a paraffin wax. The protons ejected from the paraffin wax when struck by the uncharged radiation were observed with the help of an ionization chamber. The range of the liberated protons was measured, and the interaction between the uncharged radiation and atoms of several gases was studied. Hence, it was concluded that the penetrating radiation constituted uncharged particles having approximately the same mass as a proton, and thus these particles were later termed as neutrons. In 1987, J.J. Thomson measured the ratio of electrical charge to mass of electron using cathode ray tubes. An electric and magnetic field were applied perpendicular to each other as well as to the path of the electrons. When only the electrical field is applied, electrons get deviated from the path and hit the tube at point A. Similarly, when only magnetic field is applied, the electrons deviate from the path and strike at point C. By balancing the electrical and magnetic field carefully, the path can be brought to the original straight line as it is without either fields and hit at point B. The deviation depends on the following factors. Greater is the magnitude of the negative charge, greater is the interaction with the electrical or magnetic field. Lighter is the mass of particle, greater is its deflection. Increase in either voltage across the electrodes or strength of the magnetic field increases the deflection. After measurements, it was found that the ratio is 1.758820 into 10 to the power minus 11 coulomb per kilogram. The charge on electron was found by Robert Andrews Millikan via a method called the oil drop experiment. Oil drops were allowed to enter through a tiny hole in the upper plate of the electric condenser in the form of mist produced by an atomizer. These droplets fell at a rate which was measured, and thus the mass of oil droplets were measured. A beam of X-rays were passed through the air in the chamber to ionize it. The electrical charge was acquired by collision with gaseous ions. The fall could be retarded, accelerated, or stopped, which depended upon the charge on the droplets and the strength and polarity of the voltage applied to the plate. Electrostatic force, gravitational force, and viscous drag are acting upon the droplet. Millikan measured the effects of the electrical field and concluded that the magnitude of the electrical charge on droplets is always an integral multiple of the electrical charge, that is, Q equals NE. Hence, the charge on electron was calculated to be minus 1.602176 into 10 to the power minus 19 coulomb. Using the charge to mass ratio and the electrical charge, mass of electron was found to be 9.1094 into 10 to the power minus 31 kg. The information presented in these slides are primarily collected from sources which are academic or from government organizations. I hope I could provide an overview on atoms. An elaborate discussion on the different models of atoms will be done in my upcoming video shortly. From the core of my heart, I thank you all for watching my video. To watch more videos, please check the description and also the cards appearing on the top right end of this video.